Okay, now we are having another question involving limits. So question number 13, it says given the limit of x plus k over x minus 5, the power of 2x as x going to infinity being e to the power of 28, then you are asked to find the constant k. So how it is obtained? Again, students, we need to use those properties written before. So limits as x going to infinity of this is the same as this one, students. Look, as you simply divide or you simply multiply the numerator and the denominator inside the bracket by 1 over x, students. If you multiply by 1 over x, you will obtain this to be x divided by x1 and k divided by xk over x and x divided by x1 and minus 5 times 1 over x is minus 5 over x. Then the power of 2x can follow, and this is going to be e to the power of 28. This is what you need to do whenever you encounter such kind of problem. Okay, multiply the expression inside the bracket by 1 over x. Okay, and you will obtain this one. Next, from this, you have to separate these two. You see, you have to separate these two by using this limit. So what comes next to this? Look, I'm now using lim for the upper one as x goes to infinity and lim for the lower one as x goes to infinity, because the two are identical, students. But what's happening to lim for the upper one? Remember the property. When you were having c here, this was e to the power of c. Since you are having 2 here, it's going to be e to the power of 2c, students. This is e to the power of 2c, but now your c is k, so e to the power of 2k is going to come, right? And here, your c is minus 5, so this turns to be e to the power of minus 5, but additionally you do have 2, so it's going to be e to the power of minus 5 to the power of 2, which basically is e to the power of minus 10, yeah, students? E to the power of minus 10. So you will get this to be like this. Look, this is e to the power of 2k, because as I said, you are having k here. Because of the presence of k there, you are having e to the power of k. Due to the presence of 2 here, you are having e to the power of 2k, students. And when you come to this, look, as I said earlier, this is e to the power of negative 5, but outside you have 2, so e to the power of minus 10 altogether can come. And this is going to be e to the power of 28. So our intention is to find the value of k so that this can be true. So this is very simple. Remember your lower class mathematics. Just take one of these two bases, that is e, and then subtract the exponents. 2k minus 10 makes 2k plus 10, and this turns to be e to the power of 28. This comes to be e to the power of 28 as it is directly taken from above. Now for these two to be the same, necessarily the exponents must be the same. So 2k plus 10 must be the same as 28, right? 2k plus 10 must be the same as 28. So from this one can easily determine what k is going to be, right? Because it's a matter of shifting 10 to the right, and 28 minus 10 makes 18, and then dividing that by what? By 2 makes your calculation over. So from this, 2k is going to be 18, and from this what follows is k is 9, right? It's a matter of dividing 2k by 2 throughout, and then 18 divided by 2 makes 9. So it is when k is 9 that this is the upper expression. This expression comes to be true. So having this into account, what comes next is this question, students. So I'm now offering this for you. Please try to answer please try to put your answer or to write your answer under the comment part. It says, what happens to k if this is given for you? So please apply the same procedure. Multiply the expression inside the bracket by 1 over x, and try to apply same procedure as I did above, and equate the exponents together and try to find the value of k from that. And please don't forget to write the answer under the comment part, okay? Now what comes next is the question number 14, and that is another question. So you are asked here to evaluate this limit of x squared plus 2x sine x over x minus 2 pi as x approaching to 2 pi. Can I use direct substitution here, students? I can't, because if I use direct substitution, 2 pi minus 2 pi comes 0, and everything goes to be what? 0 over 0. It will be an indeterminate type of limit, 0 over 0 form. So I am unable to obtain by using this approach, but basically you can use L'Hopital's rule. Simply derive the upper one and the lower one till you are able to substitute. In such a way we can find the limit of this one in a simple way. But let me show you another technique for this particular case. Let you assign m to be x minus 2 pi, students, no problem. If you assign m to be what? The denominator x minus 2 pi, now x turns to be, move this minus 2 pi to the right, then x is m plus 2 pi. So look, as x runs to be 2 pi, m runs to be 0, right? Because as x runs to 2 pi, as it has been stated here, m runs to be 2 pi minus 2 pi, 0. The thing I'm doing here is I'm going to completely change everything written here in terms of m. This is basically written in terms of x, now I'm going to write in terms of m. That's why I changed it. You see this expression like this. So this is the idea. In place of x, one can use m plus 2 pi, so this is squared because it says x squared. Then plus 2 into there, here in place of x, you can use m plus 2 pi, as you see. That's all about this x squared plus 2x expression. Then sign comes directly, then in place of x again, you can use m plus 2 pi. And this has to be divided by m because x minus 2 pi is m. Now from this, let's simplify what's going to happen. And from this, we can have this one. Sine of m plus 2 pi over m, directly take it from this expression, and then m plus 2 pi, the whole squared plus 2 into m plus 2 pi. You see guys, I have taken this one as you see. Now everything is written as you see, so very simple. What we can do is this one. We know that sine of m plus 2 pi from sine expansion is the same as sine m cos 2 pi plus sine 2 pi times cos m. And this makes sine m, student, because sine cos 2 pi is 1, right? So 1 times sine m is sine m, whereas sine 2 pi is 0, so 0 times cos m is 0. So sine m is the same, sine m can come. So in place of sine of m plus 2 pi, we can use sine m. Sine m. So sine m over m times this limit is going to come. Mind you, student, that you are free to substitute 0 in place of m throughout for this particular limit analysis. But as you studied before, this is 1, students. This is 1 because remember the limit of sine x over x as x approaching 0 is 1. It's a matter of changing x by m, nothing else. So this turns to be 1 into, substituting 0 here, 0 plus 2 pi is 2 pi squared, 4 pi squared can come. Here also 0 plus 2 pi is 2 pi, so 2 times 2 pi is 4 pi. So look, previously we were having 1, so 1 comes directly as you see, 1 times 4 pi squared plus 4 pi can come. This is going to be 4 pi squared plus 4 pi. So the limit of the given function exists, and that is obtained to be 4 pi squared plus 4 pi. Basically, as I said earlier, this can also be done by using L'Hopital's approach or application of derivative concepts. Simply derive the upper, the numerator first, and the denominator second, and then substitute 2 pi throughout x. You will finally come across with the same output, 4 pi squared plus 4 pi. Next, this is, see, the one I told you now. The limit of the given function is 4 pi squared plus 4 pi. For you, I have now another question. It says, evaluate the limit of x sine of x minus pi over x minus pi as x approaching 2 pi. Basically, there are different techniques to find this again. You can use again L'Hopital's rule or derivative approach to find this limit, or you may use the technique I just followed here, you see, to determine this limit output. So again, I will try to forward this for you. Under this tutor, I just have given you two different questions. Please write the answer of these two, separating writing horizontally by separating a comma. I will expect your answer to see.